Next, we'll look at what happens if there's another change. What happens if the price instead of 887 is 1,134? So 887 is a discount, compared to 1,000. 1134 is a premium. So this is a premium bond. So let's do that here. I just replicated the information here again. So let's just do this together. What are the number of periods? It's still 10. What is the coupon rate? It's still the same, or 90. What's the PV? This is what changed, right? Because now we're paying a different amount. Negative 1134.2. And what's the future value? Still the same. It's the face of the bond, 1,000. So now we're ready to go. So the yield to maturity equals rate, open parens, number of periods, 10, comma, number of payments, amount of annual payment plus 90, comma. What is the PV, which is the price you pay out of pocket, negative 1134, comma. And what's the future value, face amount, 1,000, and there we go. So this is the interest rate. What I should have done earlier was expand the number of digits so you could see a little bit more. So it's 7.08, and compared to this one previously is 10.91. So we could see the yield to maturity is quite different, but directionally it should start to make sense to you, is that if you're paying at a discount, your yield will be higher than the coupon rate. If you're paying a premium, then your yield that you require is lower than the coupon rate, and that's what we just illustrated. We can look at some of these characteristics, so that if the coupon rate is less than the rate required, then we would have what? A premium, a discount, or par, right? Think about it. If the rate desired is higher than the coupon, then we need a discount. If the coupon rate is equal, that's par, right? So that's at a par rate. And if the coupon rate is less than the desired rate, then it becomes a premium bond. So there's other useful definitions we often use. We've been looking at a yield to maturity, which again assumes that we buy the bond and sit on it for the entire period of time. But sometimes we want to measure what's our yield components. What is our current yield every year compared to what is a capital gain or loss yield? So let me just go through that by way of example. Current yield is equal to the annual coupon payment, the cash paid, divided by the current price. So again, in the previous example, we paid $877, but we're getting $90 a year in interest. So the yield is 90 divided by 877. That is greater than 10%. We also know that the yield to maturity in that case was 10.91. The rest of it is this other inclination of what is the change in price divided by the beginning price. That combination gives us our total return. If the yield to maturity is 10.91, we can determine the current yield of the cash you get, 90, divided by the cash you paid, 887. And so that is a cash yield or current yield of 10.15%. Now, the yield to maturity is 10.91. When we subtract from it our cash yield or the current yield, that result is that the rest of it, 0.76, is a capital gain yield that we could expect from this transaction. Because the yield to an investor is broken into two components. What are you getting currently, year in, year out, cash compared to what you paid? That's the current yield. And then how much extra you get. You recall that if you're buying at a discount, like in this case 877, the little extra of $123, that boosts your yield even further. And that boost in this case was worth 0.76.